Alright, now let's look at this series circuit and how we would solve that. Now this is a series circuit, and remember what we know about a series circuit is that all the current that leaves the negative terminal of this battery is going to go through every component. So the current all the way through this is the same at every component. The voltage drop is going to be different at every component. So I'm just going to label these R1, R2, R3, okay? And I want to know the voltage drop against each resistor, across each resistor, and I would like to also know the total current, all right? To do that, I need to combine the resistors. They're in series so that we know that we need to use that equation to find the equivalent resistance. So the equivalent resistance, REQ, is going to be equal to R1 plus R2 plus R3. And that means it will be 1,200 ohms plus 470 ohms plus 220 ohms. Oops. So REQ is going to be equal to 1,890 ohms. So now I'm going to draw the equivalent circuit for you for that. Okay? And it's going to look like this. Because we've reduced that circuit now to be equivalent to this circuit. Alright? And when we look at that, okay, and I want to know I, I'm going to use Ohm's law, right? V equals I times R. And if I want to know I can either rearrange this or use my triangle, and I get I equals V over R. Alright, so I is going to be equal to 12 volts divided by 1,890 ohms. So I is going to be equal to I get 0.006. Now I get a lot of decimals here, but I'm going to carry at least more than I want to end up with in the final answer. The reason is I don't want to make a rounding error, so I end up saying it's 0.00635 amps, okay? And that's part of the answer to my problem. So now I know that I have that current going through this circuit, and I can calculate the voltage drop across each resistor. So if I go back and I'm looking at that, alright, I know that V1 is going to be equal to I, which is the same for all of them, times R1. So that's going to be 0.00635 amps times 1,200 ohms. And V1 is going to be equal to 7.62 volts. Okay? Now if I want to do V2, it's going to be I times R2, so it'll be 0.00635 amps times 470 ohms, and that's going to be equal to 2.98 volts. for V2. Okay? And then V3 will be I times R3. So it'll be 0.00635 amps times 220 ohms is equal to 1.40 volts. Okay, so let's think about it. The 1,200 ohm resistor had the greatest voltage loss. Does that make sense? Yeah. You're going to lose more of that 12 volts across the largest resistor. So the one that's smallest should have the smallest number, and the one that's in the middle. So I don't know if my answers are exactly right, but I have a good idea that I'm on the right track. The other way I can check this then is, as I cross all the resistances in the circuit, the overall resistance that's lost, voltage that's lost, should add up to my source voltage. So let's check it. Alright, so I'm going to add those. 7.62 plus 2.98 plus 1.40. And actually, that time I got 12 volts on the money. So they won't usually work out to be exactly because of rounding errors, but you see in this case they did, and so our problem works perfectly. So that's an example of a series circuit.